All right, so I'm hoping that as we go through these problems, you're starting to get kind of a flavor of how this works, and you get a sense of how well prepared you are through the study of calculus that we've had this last year. The AP test is written by professors and AP calculus teachers throughout the United States that have significant experience. So honestly, if you're doing okay on these and it makes sense to you, and so far the feedback that I've had has been very, very good. I'm feeling really, really good about how you guys have done. I'm sorry that we're not together, but I still feel like you've actually learned what it is that I set out to do with you guys. So anyway, you're going to see some strong similarities between this problem and the one that we did before, which is the 2014 number 3, and it turns out this is 2016 number 3. So in seeing that repetition, that kind of tells you how significant to displaying your understanding of mathematics these particular questions are. So here we go. Let's go ahead and take a look at this new one, which is 2016, number 3. So again, just like that previous problem, we have a graph of f, which is made up of a bunch of little linear segments. So they're not asking you to decide whether those things have a constant rate of change. They're simply telling you that it is. And just like that last problem, the integral goes from 2 to x, which is interesting because 2 is right here. So if x is picked to the left, then that means we're going to have kind of a backwards integral that we're going to have to make an adjustment for. And so here we go. So it says, does g have a relative minimum or relative maximum or neither as you proceed at number 10? So the question is what does it mean to have a minimum? So let's see. A minimum if g prime of x. Now, what a minimum would be decreasing followed by increasing. So I would want if g prime of x goes from below 0 to g prime of x goes above 0 at x equals 10. It's a maximum if the derivative goes from positive to negative. So if g prime of x goes from above 0 to g prime of x being below 0 at x equals 10. So that's the only way that that could happen. However, g prime of x, which is f of x, well, what I notice is at the number 10, all of the values here are negative. So, but f of x is less than or equal to 0 for all values of x between 8 and 12, isn't it? So it had to have actually changed signs, and it never does. So this is neither a max or min or a minimum. Okay, now, then they're going to ask about a point of inflection. We haven't seen that in that previous problem. So what the definition of a point of inflection is if g double prime of x changes signs. Is a point of inflection. Now, it's kind of important that I know, that I kind of demonstrate that I know what that word means. So g double prime of x, which of course is f prime of x. And so what I want to find out is at x equals 4, does the slope of f, so this is f, so does the slope of f change signs at 4? Well, it went from positive to negative. So I can say this is a point, this is a point of inflection. At x equals 4, since f prime of x is greater than 0 on greater than or equal to 0, maybe I should say on 2 to 4, for x from 2 to 4, and f prime of x, is less than or equal to 0 from 4 to 6. So keep in mind, to demonstrate that something was a point of inflection, we needed to say that f prime changed signs, and it clearly did change signs. Now, the next part of this question is it's not necessarily a difficult question, but it is definitely a very, very long question. Because if you want to find the optimal value of a function, the absolute max or the absolute min, then you actually have to not only find the value where the derivative would be 0, but it's actually kind of more than that. We actually need to check our endpoints. So for max and min, we must check endpoints. So that tells me I'm going to have to find g of -4 and g of 12. But then I'm also going to have to find and where g prime of x changes signs. Because keep in mind, a maximum is going to occur where that goes from increasing to decreasing, and a minimum would go from decreasing to increasing. So what I need to do is figure out where is g prime changing signs. Well, we actually kind of know where g prime, because g prime is f, and f changes signs right here at -2. It stays positive, it stays, all of a sudden it changed signs here. So it changes signs at -2 and 6. So our candidates are g of -4, because that's an end point. We need to look at g of -2, because g prime changes signs. We want to look at g of 6, because it also changes signs, and we're going to look at g of 12. Now, g of -4 tells me to integrate from 2 to x, but x is, of course, -4 of f of t dt, which, of course, we need to change this bounds because of the fact that these are upside down. So we're going to go -2 to 2 f of t dt. So we're going to have to do a little bit of geometry on this problem. So if I want to find the slope, the area under the curve from -4 to +2, notice the area of this triangle right here has a height of 4, base of 2, so 4 times 2 is 8. Cut that in half, I got 4. So the area of that triangle is 4, but I need to make it negative because it's sitting underneath the curve. Then from -2 to 2 has a nice little triangle, base of 4, height of 4. 4 times 4 is 16, so the area of that curve is 8. And so if you put that together, we end up with 4 inside, but that negative. So that tells me that the slope of that, the area under that curve, as you proceed from the far left to the number 2, is actually -4. Now, g of -2 also does the same thing. It's from 2 to -2 of f of t dt, which is negative slope from -2 to 2 of f of t dt. We actually thankfully already found this answer before. That's always scary if you made a mistake before, but we actually already found that answer is 8. So far this appears to be the minimum, and that looks like it could be the maximum, but there's a lot more that we need to do. Now, when we go from 2 to 6 of f of t dt, let's see, what happens as we proceed from 2 to 6? Well, we again have a base of 4. We have a height of 4, which gets 4 times 4 is 16. So again, I guess that gives us a simple area of 8, and I didn't need to do anything fancy that time. And then from 2 to 12, f of t dt would be, as I go from 2 to 12, I'm going to be accumulating all these areas. So I've got this 8 right here. As I go from 6 to 10, I have the same triangle that I had right here, but instead of being a +8, it's going to be a -8. And then as I go on from 10 to 12, we've got a base of 2 and a height of 4, so 2 times 4 is 8. So we have another area of 4, but it's underneath the axis, for a grand total of -4. So if we're trying to find out where that max and min happens, it appears that the largest value that I see out of all of those is 6. So g of 6 is an absolute maximum, and the absolute minimum appears to be happening at g of -2. Now, for me, this is actually the hardest problem, this last one, and that's not atypical that the last one throws you for some kind of a little bit of a loop. And so they're asking, find the intervals where g, now keep in mind, g was the integral from negative, well, let's see, g was the integral from 2 to x of f of t dt. And the question is when is that negative? So when are we getting negative answers? Well, we had a little bit of a hint over here that when we looked at g of -4 and g of -2, we kept getting negatives. So this one kind of bothered me when I looked at it. So clearly, as I try -4, I got a negative answer. So keep in mind, this is kind of weird, but this answer over here, although it looks negative because it's backwards, it's actually going to yield a positive answer. And although this looks positive, it's actually going to yield a negative answer as well. So for any value of x that I pick out here, this negative is overpowering this positive, and as I slide x values to the right, I'm losing more and more of this positive. So as I slide any value of x, these answers have to stay negative. So this is going to happen from -4 to the number 2, because notice that allows me to be equal to 0. And then you'll also notice that as we pick numbers, this is clearly positive, this is clearly negative. So as I slide x values over here, I'm growing and growing and growing, which is certainly not going to be negative. This is taking it away until at the number 10, this area and this area balance each other out. So it hits 0 at 10. We kind of figured that out a moment ago. And then as I proceed from 10 to 12, I get more and more of this negative happening. So, and x being from the number 10 to 12. And that ends that particular part of this question. So hopefully you got a little bit of a flavor on how to do a similar problem, but it has a couple of extra little wrinkles. I do think that part D was a little bit tricky and part C was a little bit long, but hopefully that was helpful, and please let me know how you're doing. All right, good to see you guys again.